Okay, so we go for the sets. Oh, what's going on? We today deal about the set, the concept of sets, and we'll do a few questions from the book we had here. Maybe all exercise. Better we do a lot of practice on it. Okay, so what is a set? You are reading this sets from the very beginning classes, right? So you must be knowing what is a set.
A group of combined or you can say stepwise.
Nothing like that. It's okay. One thing only I get out of you is a group. Something a group. Okay, we have a group, but this group should be well defined and distinguish it. Well distinguish it. The two things we should have in it. It should be well defined. For example, I say a set of people in Srinagar, a good people in this area. This thing is not well defined, because who are those guys who are well defined will be very tough to get it, because if I want to convert this into the elements, then I want to identify which elements, each elements. So if I say a group of natural numbers, so a set of natural numbers, right? So we understand natural number starts from 1. We can identify the elements, right? We can identify the elements. We say 1, 2, 3, 4, and ellipsis means it goes on up to the infinity. Within a curly braces, we put up a set, the boundaries, and we can get it. But if I say the people who are good in my class, so this information is not enough information to tell who the student is. So it is not well defined. So I cannot make it a set. Are you getting what I'm saying? It should be well defined. It should be well distinguished. This element, if you see here, element 2 is well distinguished from element 1. Okay? There should be no ambiguity. When you define a set, it should not have any ambiguity. There should be no confusions to understand which element we are talking of. You're getting me? This is the basic definition of set. We have done it all the time, so not to waste time on it. So then we have a very easy peasy thing. This belongs to, because if I say, for example, 3 and the set name is A, does 3 belong to A? Answer is yes. Very simple. Isn't it? Belongs to means is it contained in a set or not? And if it is not contained in a set, for example, I say 4, I say 10 belongs to A. What do you say about it? Yes or no? 10. Very good. Because it's a natural numbers. 10 is there. So minus 1 belongs to A. Is it true? So we should say does not belongs to, like this. So this thing is belongs to. If anybody has a problem, he can write. This means does not belongs to. This is very simple thing. This is just a kiddish thing, but the little more on it is that types of representation of a set. There is 2 ways we can represent a set. One is a, yes, tell me, roster form, and other is a, you have copies? Just write down with me. So roster form and set builder form. 2 ways how you can represent your set. So when I say roster form, it means that you are roasting the things. Okay? Okay? You are roasting the things means actually you are getting the elements out of it. A set builder form is something in which what you do is you have like a dialogue. You have like a dialogue. Just write it quickly. Other guys, write it quickly and look at me.
सर मैंने कुछ लिखा है
किसमें?
ये कॉलेज में लिखा है.
Okay.
rows of null set.
Yes.
Singleton set.
This is what we.
Or
This is what we're gonna do today. This is what we're gonna do today. So better you tell me. So this is good thing. That's why I say go to the college regularly. Right? You get something. Yes. You. Not getting out of your sleep. So what is the roster form? So what is a roster form? You must be knowing these things. It's very easy. Which roster form is something.
जैसे हम लिखेंगे for example natural numbers ऐसे लिखेंगे 1 2 3 4 वहाँ करके आप
Exactly.
वैसे सीधे लिखेंगे set of natural numbers
Exactly.
ना ये वो हमारी structure
Set builder form has got another name also. Can you tell me what's the name of that? Ruler method. Because it's based on some rules. You give some rules, okay? A sort of dialogue, you know? You sort of a dialogue, and roster form is actually getting each elements exactly which elements we have. What she is saying that we have like this, our natural numbers 1, 2, 3, 4, and so on. This is a roster form. A set builder form is something which says like a dialogue about this. If we say about this, we say x such that x, okay, belongs to, oh, what is this? Belongs to, this is like a chain set of natural numbers, so it belongs to n. Simple. Curly brace. This is my set builder form. It gives like a rules. So when you say in this form, you have to say beginning and end of the elements. When you say natural numbers, it has both things. The beginning is the 1 and the end is the infinity. So I don't have to say anything other than that. So x belongs to n. It's read as x such that x belongs to n. Getting me? This is the set builder and roster form. We'll do some questions on it. We'll do a lot of practice on it. Don't worry.
फिर अब क्या होता है roster form ये हमें example दी मतलब ऐसे ऐसे होता है उसमें ऐसे होता है इसमें ऐसे होता है तो
Yes.
मैं किसी को बोलना है क्या होता है
So where we have the exact elements. The roster form, in roster form we have the exact elements. And in the set builder form, we have a rule or a dialogue. Okay? Very simple. I don't think there's anything in it. And he has written a lot of definitions also from the book or something else. You guy, you have written the definitions also. What is the definition?
roster form x such that x is even prime number.
This is the set builder form. You must have some confusions. This is a set builder form, and that roster form is where you have the elements, right? Okay. There must be some confusion. Sets is a very easy thing. It's not like that. It's the 8th standard stuff. So there must be some confusion. इतना भी गिरावट नहीं आएगी. Okay. Okay. Now there are some sets, well-defined sets. You know, well-known sets, we can say. One is the n. What is n? Set of natural numbers. When I say w, whole numbers, set of whole numbers. So it is a set of whole numbers, set of whole numbers, natural numbers, right? Z, set of integers. R, sorry, we should say Q. What is it? It is the rational numbers, right? And then we have the R, means the real numbers. Okay? Getting me? So we'll also see some examples from the book. Yes. Then we have C. What is C? Yeah, tell me, we have C. We have read a lot of things about C. What is C? Complex number. It is a set of complex number. So if we have to write it in a set builder form, what we say x such that, yes. So I simply we say x plus, no formula we have actually here, x plus I times y, or a plus I times b. That's the same thing, is it? Okay, then can you tell me what is x comma y belongs to? Here x comma y belongs to what? And I is exactly equal to under root of minus 1, root minus 1. We have done it, na? Complex number, na? X comma y can be real, and I is exactly equal to what? Minus 1. It doesn't belong to anything, it is exactly equal to minus 1, under root of minus 1. And x comma y belongs to R. Okay? Now there are, if you have, this is a very simple thing, but if you have questions, don't worry, ask. Now if we say sometimes null set, what is a null set? It is an empty set. Means, what is the roster form of it? This is the roster form. Look at the monitor. This is the roster form of the null set, right? Nothing inside. It is also shown by? Not phi. Phi is a Greek word, that is this thing, straight one. Okay? This is shown by a little tilted thing. This is a Danish word. Like this. It's a little same, but the phi, which you say phi, it is straight one. And this is oi, not the phi. Okay? This is a Danish word. This is a Danish letter, sorry, not word. It's called oi. Okay, not phi. Phi is different. Don't confuse phi with the oi, because they look little similar, but the phi is a straight one, the oi is a little tilted. It is a Danish. For a null set, it is not phi, it's oi. You getting me? It's not phi. No, phi is different. Phi is not used for null set. Whatever. Now listen. You got what I'm saying?
Yes, sir.
Okay. Now we have other thing what's called as a singleton set,
One element.
which has only one element, like we have here 2. It's a singleton set. If I say like this, A is equal to, okay, x such that x is an even prime number. Can you tell me what is the prime number first? Which is divisible by itself only. And all prime numbers are odd except 2. 2 is the only even prime number. So what is the roster form of it? What is the roster form of this? Only 2. 2 is the only even prime number. Right? So this is a singleton set. It's a perfect example of singleton set. Okay. Then which set? Finite set. Okay, beautiful. Finite set. Finite set means something which doesn't have an ellipsis. Okay, it doesn't have an ellipsis. It's finite. Like I'm saying, A is equal to x such that x, okay, belongs to n, comma, x is less than 5. This is my set builder form. X such that x belongs to n. That's a set of natural numbers. That means the beginning is n. Means beginning is from 1 and less than 5 means up to
4.
Beautiful. So what is this A equal to? This is basically equal to 1, 2, 3 and 4. So this is a finite set. It has a limited, right? Then if we say finite, then there should be also the infinite. Okay, what is about infinite set? Yeah, like A is equal to x such that x, yes, is a natural number. So what will be what is this form called? Set Builder form.
Yes, sir.
And what is the roster form of it?
1, 2, 3, 4, 5.
This is infinite set.
सर हम लिखेंगे is a natural number की set of natural number.
ये तो खुद ही सेट है ना, इज ऑलरेडी इन ए सेट. सेट के अंदर लिख रहे हो ना आप, यू आर राइटिंग इनसाइड द सेट. So you have to basically say what is this x equal to. X is a natural number. So कोई भी नंबर जो नेचुरल होगा वो x can be 1, x can be 2, x can be 3, x can be 4. So x is what? X is a natural number. अगर आप ऐसे लिखोगे, ये आप सेट बता रहे हो ना, वो आप इसे लिखोगे x is a set of natural number. I will say x, I will say a is a set of natural number. Then you can write like this. Now a is a set of natural number. That means a actually is something, a set like this, brace. A is a set of natural number. So what is a natural number? X such that x
Is that natural number?
belongs to n, or this thing is a natural number. Or in short, we can say x as x belongs to n. Yes, because n we know it's a well-defined set of natural number. So when you say inside the set, you cannot say set of. Are you getting me? When you say outside, then you can say yes. Power. Shouldn't we say first the subset?
Subsets, yes, sir. उसके बाद पहले subset.
सबसेट के दो है, प्रॉपर सबसेट एंड इम्प्रॉपर सबसेट. राइट? ठीक है, proper subset, improper subset. Now what is a proper subset? So this is very simple, no?
Improper आप बोल
Proper subset.
एक एलिमेंट कम होना चाहिए वो भी सेट हो.
Yes, exactly. If you say for example 1, 2, 3, 4, 5, this is my set, then my B, if it's a proper subset, it should have one element lesser. Even if I say C 1, 2, 3, 4 and 5, this is also a subset. I can say C is a subset, and a proper subset will have a symbol of this. Okay, improper subset will have this and equal to. So C is a improper subset of A. That means either the elements can be lesser or equal to A. Now here if you could see, your C and A, they have same elements, okay? Or I could have another set like I'm having D, which is having only one. It's having only one in it. So is D subset of A? It is the proper subset, right? Yes, D is a subset of A. So I can write D is a subset of A. Something like that. Okay, subset you can understand. You getting what I'm saying? Sure? So if I say E, for example, now tell me this thing, this is my E, and it is nothing inside. So is it a subset? Yes, it is, because there's nothing in it.
Every element contains Y.
Every element contains Y. Every set contains Y. Not every element. Every set contains.
Y.
Yes. So if you have an Y, means null set or empty set, then it is a subset.
E belongs to A.
It is a subset, right? That too a proper subset of A. Okay? So this is about the subsets. And there is also the thing called superset. We can say like this, that this A, जिसमें आप सारे ले रहे हैं ना, जो A है, we take everything from this A. So we can take A as a universal set. A as what?
Universal set.
A universal set means something out of which you can take everything then last. So if I say complex numbers, if I say complex set of complex numbers, it has everything in it. It has in it the imaginary numbers, okay, and also the real numbers. And then real numbers will have all things in it, right? It has the integers in it, it has the rational number in it, it has the irrational numbers in it, and everything in it. So complex number is a universal set shown by the U, okay? And if I'm saying imaginary number is a subset of complex number, right? So I say imaginary number is a subset of complex number. But what complex number is not a subset of imaginary, right? It is a superset, shown by like this, ulta. This guy is a subset, but this guy is a superset. Complex number is a superset of imaginary numbers. So universal set is something where from you can take everything, right? Good. Power set. Then we have a power set. Power set says that how many subsets you can have, right? How many subsets you can have, that's a power set. If you say A is equal 1, 2 and 3, for example, how many subsets you can have? Remember, the number of sets you have, number of elements you have, how many number of elements you have here? 3. The power set P will be equal to 2 raised to number of power set, right? The power set means set of all those sets. It's a set of sets which are subset of this. Power set is a set of all those sets which is a subset of. So power subset is like this. Listen, power subset P is equal to this is a whole thing, and inside we have sets. Like we have null set, we have 1. These are the elements. The sets itself are the elements of the power set. Like 1, 2, 3 is an element of this set A. The power set has sets as an element. It is a set of subsets of A. Set of subsets. So how many subsets of A will we have? What is the number of the elements in this power set is equal to the what are the numbers here? 3. That is 2 raised to power 3. That is how much here? So we have 8 such. So if you see, this is a null set, then 1. Start combining 1 with 2, then 1 with 3, then 2 with 3. Yes, 2 khali. Okay. 2 with 1 वो आ चुका है ना? Khali 3. And we can also the 1, 2, 3. वो आ गया ना यहाँ पे? 1, 2, 3, 4, 5, 6, 7 और 8. This is the power set is a subset of these guys, right? So power set is the subset of these guys. It starts from here. यहाँ से पावर सेट यहाँ से शुरू होता है, यहाँ से यहाँ तक, ठीक है? और ये जो बंदे सारे हैं इसके एलिमेंट्स हैं. And what are these elements basically? These are basically what? The sets themselves. Sets of what? It's actually basically subsets of the set A. Getting? Okay. If it is a if somebody tells you that if we have a power set, okay, tell me how many elements will be in a power set. Okay, how many elements will be in a power set is equal to 2 raised to power n, is it? If n is the number of elements in your set. Here n was 3, here n was 3, so we have 2 raised to power 3, 8. Now what will be the number of elements in a power set? But if we do not have a subsets, rather we have proper subsets. How many elements then will be in the power set then? If we do not have subsets only, we have proper subsets, not subsets. लेकिन जो बंदे proper subset होने वाले हैं, one less, because only this guy will not come. ये वाला नहीं आएगा ना, क्योंकि ये proper subset नहीं है, बाकी तो सब proper subset है ना. So that will be equal to 2 raised to power n minus 1. if we are talking of proper subsets. You getting me? Then we have one more thing, that's called equal set.
Equal and equivalent.
Yes. What is the equal set? If we have set A is equal 1, 2, 3 and set B is equal to 1, 2, 3, then we say they are equal. Equal sets means जो elements A के हैं वो ही B में होने चाहिए, same. They should be in a B also. But what about the equality sets?
सर अगर जैसे इक्वल सेट में 1 2 3 इसमें 1 2 3 उसमें
equivalent है?
सर अगर A में होंगे 1 2 3 B में होगा 1 2.
Yes.
इक्वल है?
नहीं होंगे. Equal means that element should be same.
जितने हैं उसमें इतने हैं.
हाँ, अगर हमारे पास सिचुएशन ऐसी है कि A में हमारे पास है 1 2 3 और B में हमारे पास है 4 5 6. These are equivalent set but not equal. Equivalent means number of elements. What is number of elements in A? 3. What is number of elements in B? 3. But are they same? No. So they are not equal sets, rather they are equivalent sets.
इक्वल सेट्स में क्या होना चाहिए? एलिमेंट्स भी सेम हो.
एलिमेंट सेम होने चाहिए और क्या?
एलिमेंट्स सेम है नंबर है इसमें.
सही पाने से यस. तो एलिमेंट सेम आपके होंगे तो नंबर तो बराबर ही होंगे ना. लेकिन इक्विवेलेंट सेट में खाली नंबर बराबर होना चाहिए, चाहे एलिमेंट कोई भी हो. इक्विवेलेंट मींस आई थिंक. और कोई बचा इसमें से? सबसेट भी हो गया, यूनिट सेट भी हो गया, पावर सेट भी हो गया, नल सेट भी हो गया, फिनाइट भी हो गया. एनीथिंग लेफ्ट आपके डेफिनेशन में? इस बुक में भी कुछ नहीं बचा.
सर अब ये है यूनियन सेट, इंटरसेक्शन,
वो बाद में, पहले इसका कर रहे थे. पहले इसके एग्जाम्पल्स करेंगे अब, ठीक है. सो वी हैव अ क्वेश्चन हियर. सो नाउ क्वेश्चंस. सो सिट प्रॉपर्ली एंड स्टार्ट थिंकिंग अबाउट इट. We have A is equal to 3x such that 4 less than equal to x less than equal to 8 comma x belongs to n. So is this a set builder form or is this a roster form? 3x such that 4 is less than equal to x, x less than equal to 8. Is this for set builder or roster form? It is set builder form and it's talking about x. We have 3 times x. What? Look here. We have 3 times x, but what is the x? X can take value from 4 to 8. Is it? This is a range. If you say range from y to y, x can take value from 4 to 8. So x can take value either 4, okay? When the x is 4, what will be 3 times x? 3 into 4, that is 12. So first element I am getting is 12. So now x can be 5 also, right? 3 into 5, that is, second element will be 15. So next element will be 18. Why you say 7? 5 की बात क्या आता है? 6 से 18. Oh, 7 से 21. Yes. और 8 भी आएगा ना? So ये बंदे हमारे इसके रोस्टर फॉर्म में. The question is to make in a roster form out of it. अच्छा, एक अहम सवाल जो है, जो कि ये उतारा आपने? वालेकुम अस्सलाम रहमतुल्लाह. Now we go for the next question, which says b is equal to x such that x square minus 3x plus 2 is equal to 0. This is my set builder form and I have to build it in a roster form. Okay. Now what is this thing is, how to get it from it, because this is a quadratic equation, right? if you could see here, this is my quadratic equation. If you got a quadratic equation, you have to solve it by splitting the midterm. How we solve is by splitting the midterm. Understand it carefully, you guys. Okay, what I'm saying is, when you have a quadratic equation, you have to solve it, because I have to get this is set Builder form, I have to get it in a roster form. So the quadratic equations need a solution. And how we do it is a very simple thing. We split by midterm, splitting the midterm. How we do it is very simple. If you must have forgot it, because you have non-math stream also here. Your non-math streams, and you must have forgot it and not used it. This is long back in the school you did things. But if you have forgot, we do it like this. Listen, we separate this midterm. This is the midterm, right? We have, basically we have, if you do it in a rough, we have x square minus 3x plus 2 is equal to 0. This 3x need to be split. How we separate it is a rule. What is the rule, you tell us? या मैं इसको ऐसे सेपरेट करूंगा कि जो बंदे मैं यहाँ पे लिखूंगा, दो चीज़ें मैं लिखूंगा, उनका मल्टीप्लाई निकलना चाहिए बराबर इन दोनों के मल्टीप्लाई, जो कोफिशिएंट्स यहाँ पे और जो कांस्टेंट है. फिलहाल इसके पास यहाँ पे 1 है, कल 2 भी हो सकता है, मान लीजिए यहाँ पे 2 है, देन 2 2 इज इक्वल 4. इन दोनों का मल्टीप्लाई 4 आना चाहिए, ठीक है, और इन दोनों का सम आना चाहिए इसके बराबर, क्योंकि हम इसको डिस्ट्रॉय तो नहीं कर सकते ना 3x को. वी कैन डिस्ट्रॉय 3x बिकॉज जो 3x है वो वही रखना है. लेकिन ऐसे स्प्लिट करना है कि जो दो चीज़ों में स्प्लिट करेंगे हम, उन दोनों का मल्टीप्लाई कोफिशिएंट्स का वो बराबर आना चाहिए मल्टीप्लाई ऑफ द कांस्टेंट इनटू द फर्स्ट टर्म्स कोफिशिएंट. ओके, और सम आना चाहिए बराबर जो हमारे पास टर्म है. सो वी से x square minus 3x plus 2 is equal to 0. We say splitting the midterm, right? So let's split the midterm. Basically we are trying to split this 3x, and our multiply should be 2 into 1, because here is 1, multiply of that should be 1 into 2, right? 1 into 2 is 2. So I'm having a situation that is x square, right? When I split it, I will say minus x plus, no, not plus, even minus, because I have the negative. Okay,
minus 2 minus 1,
minus x and minus 2x plus मेरा अपना है plus 2 is equal to 0. Now I split this 3x, right? I have split this 3x into these two. Now what is minus x minus 2x? That is minus 3x. That is same, right? But what is the coefficient of x? 1. Here what is the coefficient of x? 1. What is the coefficient of this x? 2. 2 into 1 is, वही आ गया ना मुझे, जो मेरा था यहाँ पे 2 और यहाँ पे 1 है. इन दोनों का मल्टीप्लाई आना चाहिए जो इन दोनों का मल्टीप्लाई है, और इन दोनों का सम आना चाहिए इसके बराबर, 3x के बराबर. You getting me? Okay. So now you can solve it. Now what we'll do is, इसमें से मैं x कॉमन निकालूंगा यहाँ पे. What we left out here? X into x is x square minus x into 1 is x, right? Minus 2 अगर आप कॉमन निकालोगे इसमें, so what will be here? That will be x into 2 is 2x, negative 2x, right? Minus is plus, because plus आना चाहिए, minus is plus, and 2 into 1 is 2. 2 into 1 is this 2 is equal to 0, right? So x minus 1 common निकलेगा और x minus 2. So we have x minus 2 into x minus 1 is equal to 0. Now it becomes easy to solve. Now this becomes easy to solve. X minus 2 into x minus 1 is equal to 0. So if I want this 0, if I want this 0, right, I can put x as 2. If I put x as 2, so what is this 2 minus 2? What is that? 0. 0 into anything is 0. So I will get the answer 0, right? And if I put or I can put here x as 1. What is 1 minus 1? 0 into whatever it is, that will be 0. So it will get answer 0. So what will be in a roster form then? It will be either 1 or 2. That is my answer. Because I want that this should be equal to 0, right? I want that this guy should be equal to 0. This guy is equal to 0, this quadratic equation. And I split the midterm, and I'm seeing that if I put x is equal to 2 or x is equal to 1, I'm getting the answer 0. So my roster form will be 1, 2. Does it make sense? Sure? This is your roster form. Okay? It seems we're running out of time. So this is the end of this segment, and we will carry on with these examples and all next time.